Hello everyone, I wanted to take this opportunity to show you how to use what we call a Punnett Square, and then how to use that Punnett Square to set up and perform what we also refer to as a monohybrid cross. So what you'll see here on this page first, we have a nice little square down here. This is what we call a Punnett Square, and we're going to use that to figure out when two parents are crossed, what could their possible offspring look like. That's the key that we want to use here for. And when we use these boxes, as you'll see in a moment, you're going to put the genotype of one parent above. So you'd put the two possible alleles there for one parent. And then the second parent, you would put their two possible alleles on the left-hand side here. And then you would just cross multiply. All right, these two go together in this box. These two go together in this box, etc. So let me show you how to do that. So what we're going to do is we're going to perform, again, a monohybrid cross now. Mono means one. So we're only going to look at how one trait is passed on from two parents to one possible offspring. So let's begin by reading this problem here. All right, so in this problem, it says, in pea plants, yellow, I just highlighted there, all right, yellow peas are dominant over green peas. All right, so what's that tell me? That tells me that as long as I have one big Y, I'm going to be yellow in color if I follow Mendel's law of dominance. So whatever the other allele is, either a capital Y or a lowercase y, I will still produce yellow offspring. If green is recessive, or yellow is dominant over green, the only way to ever see green is you would have to be homozygous recessive. So two lowercase y's in this instance, and that would produce a green colored offspring. So what we need to take from this now is we need to follow along with that. For example, this parent right here can only donate one of these two alleles to their offspring. That's the law of segregation. Same thing for this parent here, can only donate one of those two lowercase y's to their offspring. So if we go down here and use the box and perform our Punnett Square here, I can immediately, in a second here, start to put a parent's genotype here and a parent's genotype here, depending on what they are. But we're not sure yet. Let's read the rest of the problem. Never jump to conclusions. So if I read along with the rest of the problem now, it's going to ask for, it says, if a homozygous yellow pea plant, let's stop right there. They're homozygous yellow. Homozygous means same. Yellow is the dominant trait, so I know the first parent is two big Y's. Now we can continue reading. They are crossed with a green-colored pea plant. Well, we already said over here that green has to be homozygous recessive, so we know the other parent has to be two little Y's. Now we just need to figure out what does the problem actually want us to answer. So it says, what would be the probability, that's what we have to answer right there, that they'll produce pea plants that are green in color. So I'm looking for, will these two parents here produce offspring who are green, and then answer that as either a percentage or fraction for probability. So let's set up our Punnett Square. Let's take the first parent who's yellow, and I'm going to put, there are two alleles for that gene right there, and I'll take the parent who's green and put their alleles over here. And now I'll do my cross multiplying. I'm always going to put the dominant allele in front. I want to see what all these possible offspring could look like. So there we go. Whenever these two parents have kids, they have four possible outcomes their child could be. And in this instance, you could see that all four would always have the exact same genotype. Now, what the problem wants to know is, could this couple ever have a green-colored plant or pea plant, which is two lowercase y's? That's a no. So for my answer, I'm going to put 0%, or you could also write it as a fraction and write 0 out of 4. That's the answer to the problem. Now you're done. However, you can see I have two things written down. I have genotypic ratio and phenotypic ratio. Sometimes, as you perform other problems, especially in your homework, the problem may also ask for either a genotypic or phenotypic ratio. Genotypic ratio simply means how many individuals are one genotype, again, this is a genotype, versus any other possibility. In this instance, all 4 offspring will be heterozygous. So I would write it as 4 big Y little y to 0. There's no other options. Or if you wanted to, you could reduce that and make it 1 big Y little y to 0. Either would be correct. In regards to phenotypic ratio, remember, phenotype means what it actually looks like. So big Y little y down here produces offspring that are yellow. That's the phenotype. So all 4 offspring were heterozygous for being yellow, so which means my phenotypic ratio would be 4 yellow to 0. There's no other options. Or you could reduce that again and write 1 yellow to 0. And now we're all done. But again, this problem, this was the answer ultimately we were looking for. Let's do one more example. All right, so now I have another problem here. All right, and what this problem wants to know is, in humans, bushy eyebrows are dominant over thin eyebrows. So that means that if I have at least one big B, regardless what the second allele is, that individual will have bushy eyebrows. And again, we got that from the problem right up here. Bushy eyebrows are dominant. Now next it says thin eyebrows are recessive because bushy eyebrows are dominant over thin. So what that means for us is, in our little key over here, 2 lowercase b's, or homozygous recessive, produces thin eyebrows. And that's the only way that's ever going to be able to happen. All right, so let's figure out what the genotypes of the parents are. So as we proceed through and read here, it says, if a bushy eyebrowed man, so what that means for me so far is he has bushy eyebrows. So I know he has at least one big B. I'm not sure what the second allele is yet. I'm not going to jump to conclusions. But it says whose mother had thin eyebrows. Now, why is that there? That's there to clue you in on what his second allele should be. So his mom has thin eyebrows, which is this genotype here. If you follow the rules of segregation, his mother could have only given him one of those 2 alleles. They're both lowercase b's. So that means he is heterozygous for his bushy eyebrows. Now, he's going to be mated with a woman. Let's see what this woman is here. He marries a woman with thin eyebrows. All right, again, thin eyebrows is, once again, the recessive genotype. So he's going to be crossed with a woman who is homozygous recessive with thin eyebrows. So that means automatically, before I even read the rest of the problem, I can set up my Punnett Square below. Big B, little b for the bushy eyebrowed man. Little b for the thin eyebrowed woman that he's going to marry. So now what does the problem actually want from us? The problem wants to know what is the probability that they will have a child with thin eyebrows. So again, a percent or fraction of the chance that they're going to produce a kid that is this genotype over here. So I'm going to go through now and do my Punnett Square. Again, keeping my dominant alleles in front of the recessive ones. All right, so when I'm done, they have 4 possibilities that their children could be. And if I look at my Punnett Square I just filled out, 2 of the 4 will be heterozygous. 2 of the 4 will be homozygous recessive. So I can see that 2 of the 4 do produce a homozygous recessive genotype, which will produce thin eyebrows. Make that an H right there. So my probability that they will produce a thin eyebrow child is either 2 out of 4, or if you reduce that, you could have also written 1/2, or 50%, writing it as a fraction. So we've answered the problem. Well, let's work through again just in case we needed to answer what the genotypic or phenotypic ratio would be. Genotypic ratio would be I have two possible offspring that will be heterozygous to two offspring who will be homozygous recessive. Again, you could reduce that to 1 to 1. Phenotypically speaking, heterozygous individuals will have bushy eyebrows, so two offspring who could have bushy eyebrows, the two offspring who will have thin eyebrows. All right, now we're done. So hopefully this makes some sense now, and take what you've learned here and apply it to your monohybrid cross worksheet that you have assigned this week.